Okay, so for the seventh question, Anna has four discs of different sizes. She wants to build a tower of three discs so that each of the disc is smaller than, okay, it's smaller than the disc below it. Okay, there's a requirement. Each of the disc is smaller than the disc below it. So how many different towers can Anna make? So for here, you can see that we have like discs with the four different sizes. We can just like giving name or giving them a number, and let's starting with the smallest one. Let's put it as one, and the second smallest two, and third smallest three, and the biggest one is four. Okay, so the very easiest way for us is to use the enumeration to list them out, right? So we can just try it. If I starting from the smallest one, and then the set, I can just put the two right below it. It's bigger than the previous one. And for the next one, I can either choose three or I can either choose four, right? No matter what, it's bigger than that. Other than this, after one, I can also directly jump to number three, right? Because number three is also greater than, bigger than the number one. So I can also have one, three, and four. And besides this, I don't need one actually. I can also have two, three, and four. And can we figure out any other situations which is like each disk is smaller than the disk below it, and it's a tower of three disks? No, that's all of them, right? So basically, you're gonna have four of the disk, which is option C, right? But other than this, instead of just list them out, for example, if you see a question that's like you have 100 disks, and then you want to build a tower of 99 disks so that every disk is smaller than the disk below it. Are you also gonna try to list them out? Definitely not, right? So for this one, we're gonna find out an easier way to do this. We know that once we chose, let's see, once we choose three of the disk from the four, and the order is definitely fixed, right? For example, I choose one, four, and a two, and you cannot just put one first and four second and then two third, right? Because we have a requirement that every disk is smaller than disk below it. So the correct order is actually one, two, and four. So that means once we choose three from the four, then there's only one way to build it. That means for this question, we can just translate that or convert that into choosing three from the four disks. There are how many ways, right, everyone? Choose three from four. There are how many ways? Number of ways are how many, right? Okay, so this is gonna build foundation for the combination permutation. We're gonna learn for MCA later. But for this question, we actually have an easy way. And since you want to choose three from four, that's just simply, you can convert this one is exclude one at a time to from those four, right? You can exclude one, or you can exclude two, you can exclude three, or you can exclude four. And that's four different ways to exclude them. Okay, so this one, the four got excluded, and this one, the number three got excluded, and this one, the number two got excluded, and this one, the number one is got excluded. Okay, so this is another perspective to solve this. So if you use this way, if you want to choose 99 from the 100, you're gonna have 100 ways, right? Okay. Okay, so that's how we solve this question. And in a common core, this is pretty interesting, is the permutation and combination with constraints. So for here, our students are going to understand the combinations and some like logical reasoning. And in school, you mostly use the first method just to list all of them out, right? But that way, it's actually not very efficient for us to solve the question. So in while preparing for MK, Math Kangaroo, or MCA, we'll actually prefer you guys to do it the second way, or later when you learned like something like 3P4 or 4P3, something like 4P3 or C3, something like that. That's actually even more efficient to solve this kind of question. Okay. Okay, what about the eighth question? Denny glued the two pieces of paper. So you see there's a semicircle, the gray semicircle, and there's a white quarter circle. And without cutting them, you cannot cut them. So on the top of the black circle on the right, so the black one is actually a whole circle. So the question is asking, what can he not make? Okay, so for this one, everyone, because we cannot cut them, which means all of the shapes that's showing outside can only be smaller than the original shape, right? And it cannot be bigger, or it cannot be like separated. You can only cover some of the parts. For example, if you cover this part and you show this part, that's possible. But you cannot just, let's see, you cannot just like have something like this as a whole gray part. So that's impossible, right? So we can just go through each of the options to see if that's possible. So for here, is it possible? You can first of all put the gray one to here so that you only show half of the black one. And then you put the quarter circle, the white one here in the middle so that you can show this one. This is possible. And again, for this one, you first of all put the gray and then you actually tuck the white one, half of it under the gray one, right? So that you can only show half of the white one. So this is also possible. And for the third one, you first of all like put half of the gray here and then you put the white here. So that's also possible, right? So for the option D, you can just see that for this one, you first of all put um the great one like this, right? You first of all put the great one like this. And then you use the white one to cover like each of the half, right? You cover half of the um you use one half to cover the green one and use one half to cover the black one. So this is the white part. And so that's how you can show this. Only the last one, because you see the last one, you actually cut the gray part into two parts and separate them and to make them totally opposite with each other. So those two parts are actually not possible to make, right? So this white one is possible and the black one is possible, but for the gray one, it's impossible, okay? You don't have that range. So the last one is not possible. So the correct answer is option E. Regarding this one is actually the geometry and spatial visualization. And for this one, our Math Kangaroo question is trying to develop the spatial visualization on our students. And we also can like build some like foundation to understand the fraction from the geometry, right? So when we try to first introduce the fraction, we usually use the geometry way like this to introduce the fractions, right? And then we can also apply the logic deduction, so students evaluate opinions systematically to eliminate some impossible outcomes. So we use the elimination to solve this question.